Our directions say solve the equation for m. So if you notice at this point the equation is solved for f and we want to solve for m. Okay? So the first thing we need to do is look at this as a rational an equation containing rational expressions. So we want to clear the denominators or clear the fractions just as we would for any equation with fractions. So we need to multiply by the common denominator on both sides. Since there's only one denominator, it's easy to tell that it's d squared. That allows us to cancel the denominator. On the left side we carry out the multiplication, that's d squared times f, and on the right side we now just have negative k m n. Now we're trying to get the equation solved for m, and now m is only multiplied by negative k and n, so we should be able to divide by negative k and n, dividing to get rid of what's multiplied, and we divide by that on both sides, negative k n. So that leaves us m by itself here, and the other side I like to move the negative to the front of the equation, to the front of the expression, and write that as d squared f over, since I moved the negative, I'm just going to now write that as kn. Now, we've carried out the instructions to solve the equation for m. m is now isolated. Okay, here's another set of instructions for what looks like a function that has a rational expression in it. Okay, remember this is function notation. F of x is equal to x divided by x minus 7, or x over x minus 7. The directions are find all numbers not in the domain of the function. Remember the domain, set of all of the x values here. An important thing to notice here is that we have an x in the denominator. So, remembering that a 0 denominator is undefined, then we know that the denominator cannot be 0. So x minus 7 cannot be 0. So we could set up an inequality that reads exactly that way. X minus 7, the denominator, cannot be 0, and then we can solve for values of x. So add 7 to both sides would give us x cannot equal 7, and so that tells us since x cannot equal 7, 7 is not in the domain. Okay, and that's one way to state the answer. Another way to state the answer is x cannot equal 7. We could also write that in interval notation, but one of these is good enough for this exam. Okay, let's look at this equation. The instructions say solve by factoring. Okay, so the first thing we notice about this is this squared term here, so that says our equation is quadratic. So when we have a quadratic equation, we want to make sure it's in standard form. And so is it in standard form? Yes, it's in descending order on this side, and it's 0 on this side. That's considered standard form. And so if it is in standard form, we want to try to solve by factoring. So we want to factor the polynomial. Factor the polynomial. Alright, so we're going to say that this is the kind that might factor quickly and easily with no table because the leading coefficient is 1. So r times r for r squared. For the second terms, we want to multiply for negative 40 and add for negative 6. And so let's try 10 and 4 with a negative 10 and a positive 4. I believe that adds for negative 6r. It does. Alright, and now that we have it factored, we want to use the zero factor property. And that says that if two factors multiply for 0, one or both must be 0. So we say r minus 10. That variable factor equals 0, or r plus 4 is equal to 0. Add 10 to both sides here for r equal 10. Subtract 4 from both sides here for r equal negative 4. Alright, so that tells us r can equal 10 or negative 4. Okay, and we can take these back to the original and check them, and I suggest you do that for test A. Okay, check. First we'll check the value 10. In r squared, that would be 10 squared, minus 6 times r would be 6 times 10, minus 40. Does this equal 0? So that's 100, minus 60, minus 40 equals 0. When you run this string of calculations, you get 0. You sure do. Get 0 equals 0, so that works. 10 checks. Let's try negative 4. So when we square negative 4, minus 6 times r would be 6, not minus 6 times negative 4, minus 40. Does that equal 0? So when we square negative 4, we get 16. When we multiply negative 6 times negative 4, we get positive 24. Minus 40 equals 0. 16 plus 24 is 40, minus 40. That also checks. Okay, so both of our solutions check. Okay, our instructions for the next one here say solve the equation. Now we don't get any hints about how to solve it, so we need to look at it. We need to notice that because of the squared variable here, it is quadratic. So we're going to notice that it's quadratic. Then we want to check to see if it's in quadratic, is it in standard form? Alright, so standard form means everything on one side in descending order and 0 on the other, so that looks good. And we're going to factor the polynomial. Alright, this is a binomial, but it's not a pattern binomial, so we might look for only a greatest common factor. So 2s squared and negative 18s. 2 and negative 18 share a factor of 2. S squared and s share a factor of s. So when we factor out 2s, that leaves us one factor of s here and negative 9 here. So in factored form, this becomes 2s times s minus 9 is equal to 0. Now we need the zero factor property. Alright, and we discussed what that means already. So the factor 2s, that has a variable in it, 2s is equal to 0, or s minus 9 is equal to 0. When we divide both sides here by 2, well, that cancels the 2 there, s, and 0 divided by 2 is 0. Here we need to add 9 to both sides, so s is equal to 9. So we have s is equal to 0 or 9, and remember to check both. Okay, I'm not going to physically show the check, but 2 times 0 squared would be 0. Minus 18 times 0 is another 0. So 0 minus 0 is 0, that checks. Let's try 9. Okay, 2, well, maybe we're going to write this one out. Let's check. I don't think this will be as easy to work with in our head as the 0 was. So let's say 2 times 9 squared minus 18 times 9 is equal to 0. So remember to do exponents before multiplying, so that's 2 times 81 minus 18 times 9. And when we multiply here, we get 162. And when we multiply here, we also get 162. So 162 minus 162, that checks as well. Alright, so two solutions here, 0 and 9. Okay, here again we just get the directions to solve. We don't get any hints about what kind of equation it is. But we do see a fraction in there that we'd like to get rid of. Okay, so how do we get rid of fractions? Multiply by the least common denominator. Since there's only one denominator, it's easy to tell that the common denominator is z. Okay, so we're going to multiply both sides by z. So z times z plus z times 4 over z is equal to z times negative 5. Okay, so carrying out that multiplication, z times z is z squared. Z times 4 over z allows the z's to cancel, plus 4 equal z times negative 5z. Alright, now we've cleared the fractions, and now we need to take a look at this and recognize, because of the squared variable here, this is called a quadratic equation. It's quadratic, so that means we want it in standard form. Standard form means we need a 0 on one side, descending order on the other. So z squared plus 4, we need to add 5z to both sides to 0 out this side. So that would be z squared plus 5z plus 4. That puts that in descending order. Now we need to factor. So in order to factor this, it's the kind that we can probably do without a table because the leading coefficient is 1. So z times z for z squared, do we have numbers that will multiply for 4 and add for 5? Yes, we do. Plus 1 plus 4 multiplies for 4 and adds for 5z in the middle. Now we use the 0 factor property. Z plus 1 is equal to 0. Or z plus 4 is equal to 0. Subtract 1 from both sides, z is equal to negative 1. And subtract 4 from both sides here, z is equal to negative 4. Alright, and remember, because this equation had a variable in the denominator, that we must always check to see if both of these numbers are in the domain. Okay, do either of these numbers cause a 0 denominator here? No, they don't. Okay, they do not. So then we say the solution set includes both of those numbers.